All right, guys and gals. So I am very excited today to talk to you guys about web development. What is web development? What is front end development? What is back end development? And what is the difference between front and back end? And what should you start with? If you have any of these questions, or you've gotten into a little bit of web development and you're just lost and confused, and you're hearing things like HTML, CSS, JavaScript, freaking PHP, Node.js, all this kind of stuff, and you're just kind of lost, or you're brand new and you've never heard of any of this stuff before, and you're thinking about getting into web development, then this video is for you. If you already know a lot about web development, then this probably is not the video for you, but you may learn bits and pieces here and there. So with that said, let me get myself off the screen here, and oops. And I'm actually going to use basically like a PowerPoint here. I'm actually using this LibreOffice software, but this is kind of an ugly presentation. And the reason why is because I meant to do this for like 10 minutes and I ended up doing it for like an hour, which is good for you guys because I'm making this really thorough. But I am going to go through this pretty quickly because I feel like the way I'm going to explain the concepts here, it doesn't really need to be slow. And I know time is of the essence in society here, and we're all busy people. So I'm going to go ahead and just go through this slide by slide, and I'm going to try to keep this as interesting as possible, and really just sort of ignite the spark within you guys, especially if you're considering this as a career or as a hobby or something. So, okay, here we go. First things first, you got to understand what the internet and what the web are, because they're two different things, okay? And it's sort of like how it would be hard to explain construction to somebody who doesn't know what a building is. Okay, so what is the internet? The internet is the communication between many computers. At this point, we're talking about millions and billions of computers, okay? They're all hooked up via these wires, you know, like our network cables that we plug in, or the Wi-Fi, which ultimately connects to network cables, which, you know, think of it as a whole bunch of phones connected together, except it's a whole bunch of computers connected together via a network. That's what the internet actually is, okay? As I said, the internet is a means of communication, and it is best described as something being sent through the internet rather than something being put on the internet. So we have a tendency to say, like, get on the internet, or go search on the internet, or I'm going to go put this on the internet. And that's fine when we're talking about everyday talk. You know, nobody really cares. But when it comes to actually understanding this stuff, you don't really put something on the internet. What you do is you're putting it on a computer, and you're connecting to that computer through the internet. But we just refer to it as being put on the internet because nobody really knows or cares where that computer is and about that individual computer. We just care that whatever we're putting on the internet is accessible all over the place, which it is. So the internet is a means of communication. Keep that in mind. Okay, like I said, think of a bunch of people who all have phones who communicate on a regular basis with one another. That's what the internet is. It's a bunch of computers who all are connected to each other and communicate with each other on a regular basis. Okay, what is the World Wide Web? What is the web? It is different than the internet, okay? And it's not to be confused with the internet. The web is a group of standards and protocols that govern how most computers transmit information to one another using the internet. So this is kind of, all right, we're past the fact that a bunch of computers are hooked up and communicating. This is how they're communicating. This is, you know, what protocols and standards that these computers have to follow in order to transfer messages to and from each other. Because if the computers don't follow a standard, it's sort of like if you're trying to go to France, and in France they speak French, so that would be a standard. Everybody knows what French is in France. I mean, there's different dialects and different accents and things like that, but generally speaking, people in France can communicate in the French language. Well, it's the same thing with the web. The web allows computers, it's a set of like standards that allow computers to communicate with each other, just like how a language allows humans to communicate with each other. All right, so what is a website? To fully understand what a website is, you must first understand the client-server relationship. Before we discuss that, though, know that a website is simply a group of files and programs that are on a computer, much like your own. That's basically it. If you go into your My Computer or your Mac files and you open up, as if you're going to open up like a Word document or a picture that you want to view, okay, you're gonna transverse through something called a directory, and that is basically your listing of files. You know, you go into a folder and you pull up a list of files, and then you go to another folder, and then you get to the file that you want, and you open that. Okay, well, on the other end, on the other computer, when you go to a website, it's a similar structure. So the website is a group of files that are on another computer. And when you visit it, it's basically going through those directories just like you would, and it's pulling those files out. Okay, so that's what I want to kind of explain in this slide here. Now, what are clients and servers? All right, so this is a very important concept for you to understand if you're going to be doing any kind of web development and programming, and it's just useful information in general. Okay, these are just computers, just like yours. There's nothing fancy or special about these things. Okay, the client and the server is a relationship definition or a role definition more than it is actually a machine. So, like, when I was younger, I used to think, like, ooh, server, it must be like some awesome, like, huge computer that's way more powerful than mine, that's in some office building somewhere, that just does all these really cool, fancy things. And the truth is, that could be true. It could be a powerful machine, but it isn't necessarily true. I mean, you could run a server on your own computer. A server is just a program, just like Microsoft Word or Adobe Photoshop or any other program on a computer, like Mozilla Firefox or something like that. It is a program that runs on a computer, and that computer is designated as a machine that is just going to accept connections from other computers, basically. So that's what a server does. As I said here, server software is just that, is software. Okay, so I pretty much covered that. Okay, so it makes sense that certain computers are purpose-built servers so that they can suit the role as best as possible. Just like a garbage truck is suited for garbage collection, but it is still a truck. So exactly. So even though a server is actually just another computer like yours, there are certain things that servers would need more of or have set up differently on their hardware than your computer. So, for example, if you have a whole bunch of servers in a giant server room, every server doesn't need a computer screen. So they don't all have computer screens. And every server doesn't need a keyboard and a mouse connected to it. So they don't all have keyboards and mouses. But the actual computer part that's doing the calculations and the computing and running the programs is just like your computer. You know, it's the same type of machine. It has a processor, it has memory, and it basically does all those things the same way. Okay, but it might have certain things like more ports to plug into, and things of that nature that make it more conducive to accepting a lot of connections from the internet and from other computers. So think of it as the same thing as your computer, but just purpose-built for accepting connections from other computers rather than for displaying things on a screen and stuff like that. So now a client is your computer or any computer which accesses a server. So a client contacts a server and then, through the internet, and then that server transfers data and information back to the client using the web standards that we talked about earlier. And the client's browser or other software then interprets and displays that information that was sent through the internet from the server. So don't get too confused here. A client is just your computer. Like, my computer is a client that I'm using right now. The computer that you're on right now is also a client. It is just the machine that the end user or the kind of average person uses and connects to websites with. Okay, so what happens when you go to a website or a URL, which is a uniform resource locator? The simplified version is that the website URL simply points to a physical computer or address called an IP address. So what do I mean by this? Okay, let me stop this real quick, and I'm going to show you guys exactly what I mean by this. So I'm going to go to google.com. So you see that this is called a URL. This is a uniform resource locator, and everybody's familiar with this. It's just a .com or .net thing. So what's really going on here is that this URL is basically it's forwarding, or it is representing an IP address. So what's really going on here is when you go to google.com, you're actually going to something like 178.56.89.765. That's just an example, but that is an actual, that's the format of how an IP address is written. So instead of having people have to memorize this, which is highly impractical, because think of all the sites that you go to and trying to memorize this number, like in these types of numbers. Instead, what we do is we use these things called domain names, like google.com. And that google.com actually, when you go to that, it's hitting up a server called a name server. And that server says, okay, this client or this user wants to go to Google. Let's look up google.com and see what IP address refers to the computer that accepts connections at Google. And then it then goes and it says, okay, it's this IP address. Now take this client to that IP address. And then boom, your computer pops Google up. But it obviously does that super fast. So that's what an IP address, or that's what a domain and a URL is really doing. So now back to the slide here. Back to the presentation, I mean. Okay, so it's important, though, I need to kind of back up there because I talked about this thing called an IP address. So all an IP address really is it is a address for a computer. So when the computer is connected to the internet, it has to have a unique address. Just like how in a city, a house has a unique address. I mean, there might be a Melrose in San Diego and a Melrose in LA, but there's not going to be the exact same street name in the exact same city and the exact same street number 2 times. That's a unique address. So that way when I say go to 999 Melrose in Hollywood or in Los Angeles, if I say go to 999 Melrose in San Diego, those are 2 different places, and they're unique because there's only one of that address in each of those cities. Well, IP addresses are similar. There's only going to be one given machine using one given IP address at any given time. I mean, it can become a little more complicated than that. For example, if you have 3 or 4 computers all using the same connection in the same house, they could all share an IP address. But for simplicity's sake, let's assume that the IP address is like an address, like a house address, and it just tells one computer how to get to another. That's it. And a domain just points to an IP address. So when you type in a website in your address bar, then that's what's happening. It's saying, okay, get this IP address and go to this machine. All right, so what is a web browser and what does it do? So a web browser is often kind of mistaken for the quote-unquote internet by non-technical people. So, like, for example, I hear people say things like, for example, if they can't find the Firefox icon or the Chrome icon on their desktop or Internet Explorer, they're like, I don't know where the internet is. Where's the internet? I can't find the internet. Does this computer have internet? Okay, so what they're really saying here is they're trying to find the browser. And all the browser is it's a program that runs, that's installed on a computer, that the computer has on its hard drive or its disk drive. And it interprets the data that is given over the internet when your computer is connected to a server or another computer. So, basically the way I wrote it here is a browser is a program which is installed on the client or end user's computer, which interprets data, markup, and programming code, and displays such in the form of web pages. It sends and receives information to and from the web server, and it is the main program used to communicate with web servers. So that's pretty much it right there. I mean, as I say in the next slide here, there are other programs which are not web browsers and can and do communicate with servers on a daily basis, such as file transfer programs like FileZilla and the zillions of applications you have installed, which constantly ask you if they can send your anonymous data to their server for quality assurance purposes, as well as programs that check for and download updates. So a web browser basically goes on the internet and it connects to a server and it gets information in the form of the web, like using those web standards and protocols that we discussed earlier. And it then uses those standards to display that information that it pulled down off of the web or off of the internet, which is really from another computer called a server. So browsers read HTML, CSS, and JavaScript. This is a very important point here. The information that your client computer and web browser on your computer receive is in the form of something we call HTML, CSS, and JavaScript. HTML is simply a markup language which tells your browser which items are to be displayed on the page and in what order. CSS is a styling language which allows the web developer to position, color, and style the items on the page. So HTML and CSS work hand in hand. HTML tells the browser what is going to be on the page and in what order it's going to be in. And then CSS tells the browser what colors it needs to display, the font type, the size and positioning of the stuff on the page, and stuff like that. JavaScript, on the other hand, allows for more action and functions to go on. For example, with JavaScript, a developer can make it so that when a user clicks on a button, certain information is sent to and retrieved from the server. The page removes items and adds new ones. The page flies items around and displays them differently, and etc. JavaScript is a programming language. It features logical elements shared by many languages, such as if statements, while loops, mathematical operators, functions, and etc. All right, more about JavaScript. It is important to note that though JavaScript traditionally was the programming language of the web browser, and it still is, meaning although it contained much of the same programming elements as more powerful, quote-unquote, more powerful languages like C and C++, it was only interpreted inside of and could command a web browser like Firefox, Internet Explorer, Chrome, and etc. So in other words, this was a programming language, but it was constrained to operating only from within Firefox, Chrome, Internet Explorer, Netscape Navigator, and web browsers. It couldn't do things like, defragment your hard drive or navigate through the files on your computer or, stuff like that where, it couldn't run in a program like Microsoft Word on your computer. It could only do things from within the web browser. However, this has changed thanks to something we call Node.js, which took the browser-only JavaScript and now allows it to perform functions on the computer that only other languages such as Java, C, C++, and Python could traditionally perform. This allows JavaScript basically to essentially act as a more powerful programming language because through Node.js, it is now capable of performing a lot more powerful functions on a computer rather than just being contained in the web browser. Okay, now, if you're a little bit bombarded here, pause the video, take a break, and come back in a few minutes. So, congratulations, you now know what front-end web development is. Front-end web development is all programming and coding that is executed on the client computer. This would be HTML, CSS, and JavaScript. Together, they form front-end. Front-end is not all visual, though. For example, you could program a complex application in JavaScript, since it is a full-blown programming language, and it could run in the browser. This is why web apps are becoming more and more prevalent. Web apps are more than a traditional website. For example, Google Docs is a web app and allows you to do nearly everything that can be done in Microsoft Word. More examples are calculators and games. Although it is not all about visuals, front end is the portion of web development that is generally responsible for the visuals, styling, and presentation that a user sees on a web page or web app. Okay, so what is backend? I know I'm getting a little bit like I'm just reading these slides, but the reason why I made these slides, though, is because I didn't want to forget any of this information, and this is kind of a lot of stuff, and it would be easy for me to make this whole video and then be like, oh crap, I forgot to mention something like frameworks or like web apps or something like that. So stay with me here. We are halfway through this whole thing. So what is backend? Backend is every piece of software and program that is run on the server rather than the client. What types of programs and software are these? Databases, server software, which simply accepts incoming connections from clients, and the files and code that make up the website itself is stored on the server, even though it is referred to as front end. So this might be kind of a tricky concept here. So let's back up real quick. So you know that a server is a computer that accepts incoming connections from other computers, which we call clients. Okay. So when you go to a website, you type in whatever.com, your computer sends via your web browser, sends a request over the internet to another computer that we call a server. On that computer is a group of files, and those files make up the actual website. So that server actually has, even though it is, the actual server structure and programming is called backend, it actually has the front end as well on it, because that's where the front end comes from. So basically, when your computer contacts that server, it's saying, hey, server, display the website to me. And then that server now sends those front end files via the internet back to your computer, and then your browser takes those files, interprets them, and displays them to you. And the way it displays them is governed by HTML, CSS, and JavaScript. So does that all make sense now? Okay, so this should all start kind of coming together for you in your head now. So even though we refer to the server-side programming and processing and technologies as backend, actually the front-end stuff resides on the server too. That's my point here. So things that are server-side are databases, the actual programs on the server which are set up to listen for client connections, and the actual files and stuff that make up the website. All right, so now we need to talk about what a database is, because I didn't know what the hell a database was when I first started all this, and it can be really daunting and nerdy and confusing sounding. So let's talk about what data is. Data is simply content and information. Websites and apps are generally information-based things. For example, when you go to your favorite blog or news site, the actual text that makes up the news, forum, or blog post is data that is stored in a database. So is the author name, date, and etc. Databases store this data. All right, so before we even do that, I'm going to actually demonstrate this to you real quick. I'm going to go to a blog right now. I'm going to say Node.js blog. Let's just do this. Let's go to news, Node.js. All right, so that looks like kind of an ugly blog to me. All right, let's do this. Let's just look up NFL blog. Okay. This looks a little bit more normal here. So you see these blog posts here and this whole structure of this thing. I'm going to break this whole thing down for you real quick. I'm going to click continue reading on this post right here. All right. So this is written by this guy named Marcus Grant. And the title of this obviously is Ben Jarvis, Green Alice fighting for roster spot. Okay, so let's look at this page here. What do we got? We got a background color. We got a title here, which is actually either text or an image. Text, actually. And then we got this guy's photo. We got the title of this blog post. And then we got the content here. So the way this is working is these people are not continuously going in. Like, this guy's not a programmer, okay? He's not going in and opening up an HTML page like this and writing in his post in here like this. See, this is the actual HTML markup code that makes up this blog post here. This is what I meant by it. The server has sent this code to our browser. So what I did is I right-clicked here and I said view source, and it will actually show you the actual code. So he's not going in here on these pages and writing in his content like this. What he's doing is he's using a software that was written by a programmer that he just simply writes into easily. He just types in text like he's typing it into Microsoft Word or something. Just like if you've gone on Facebook and written a Facebook post. And the text that he writes in and the formatting is getting stored in a database. So this is all data right here. This is all data. In other words, there is a spot in the database that has this post here and this title and this author and all of this stuff. Okay, the actual content that we're reading here, and like, see how there's all these comments? This is all stored in a database. That's what that is. Now, the stuff that's not the content is not the data. It's not coming from the database. Like these pictures here and this background styling and all that, and the way the stuff's structured on the page, that's coming from the HTML and the CSS, and in some cases the JavaScript, and that's the front end stuff. Okay, so now we're done with this for now. So I'm going to go back. I'm going to go back to where I was here. So now I'm going to show you kind of how a database is structured. This is a data table example. Okay. When you look at a database, you typically look at information like this, just like an Excel spreadsheet. Okay. You're going to have what we call a database table. So let's say you have a table on your website that stores different contacts or people that you know and what company they work for. Okay. Well, each contact is going to have a unique number that that your program or that you use basically to locate them that no other contact will have. Okay. And then obviously they're going to have the first name, the last name, and the company. So this is like how a database table is basically structured in a relational database, which is the most popular type of database, like MySQL, Microsoft's SQL Server, all these different databases that are like these SQL type databases. They're all relational databases, and they store data in a similar format to this right here. But you have to understand, though, that is not how databases actually look. That's how they're displayed to us humans. But a database is simply a computer program, and although it helps us humans to visualize things in a table like I just showed you, the computer could care less, and it stores stuff in ugly formats. For example, it might store it looking like this. 0001, James Bundy, Google Inc., 0002, Sarah Hilligus, Yahoo, etc. It's super ugly and almost unreadable, blah, blah, blah. You know what I mean? It's not going to look pretty like that, and it doesn't really matter to us, but I'm just explaining that to you to basically explain that a database is nothing but another computer program and computer files. Computers ultimately process everything as numbers anyways, and the important thing to note here, though, is that the previous example is a data visualization or a database model so that we as humans can visualize and understand how the data is being stored. So now you know what data is. Back to back end. Now you understand what a database is. You can probably start to piece together what I'm getting at here. The server is simply software on a computer, which when contacted by a client computer via a web browser or another program, pulls data out of the database and or pulls pages out of its file system and then shoots that stuff back to the client, which then the client interprets and displays as a web page. All right. Now we're getting somewhere. All right. Now this is cool. This is good stuff. Now you are becoming an officially educated web guru, I guess you could say. So, programming and programs that occur on the server are called back-end technologies. So let's talk about an example here. And before I go into that, it is normal for back-end to sometimes be harder to understand at first, since most of us are familiar with the client side as we have been using it on our computers for years. But most of us have not been using and operating servers for years. In fact, there's a good chance that if you're new to this, you've never operated or used the server before on the server end of things. So say, for example, I wanted to allow only users who are registered on the website as club members to access my fitness club's fitness tips page. So say I'm a gym, and on my gym's website, we have a fitness tips page, but you can only see these fitness tips if you are a member of the gym. This would involve back-end technology and back-end, what they call back-end processing, which is basically just computer code and computer programs that are running on the server to do this kind of thing. What is really going on here? When the user tries to access the page, the user's browser sends a signal over the internet to the server computer, which then runs some computer back-end code. This code was developed by a back-end developer, and it checks whether or not the computer is logged in as a club member. If they are, it displays the fitness tips information. If not, it probably displays a page that tells the person that it is a members-only area or asks them to sign up as a member. I'm sure you guys have all seen this before. In fact, many sites will do this thing on purpose, where they will lead you to a page that can only be accessed by a member. And then when you click the link trying to see the page content, it's like, hey, wait a second, you have to register. But that's okay because registering takes 30 seconds and it's free anyways. What's going on here is that is backend at its finest. that is backend technology working right there. Okay, backend technology can do things. It basically does work, or it does processing on the server side. So it says, hey, who is this client? Is this client logged in? Are they a user we recognize? If not, then I can send this page to them. If they are, then I'm going to send a whole different page to them. So that allows computer programming to take into effect, processing. That allows us to make decisions and do dynamic things rather than just display a plain old web page that anybody can view. And that is what back-end technology, that's one of the things that back-end technology allows us to do. So anyway, yeah, in any event, they don't get access to the page unless they are a member. Piecing it all together. So the user visits a website, which hits up the server, and it says, yo, server, I'm here. The server then fires them back a web page in the form of HTML, CSS, and possibly some JavaScript. Now, JavaScript is not required. You don't have to have JavaScript in order to have a web page, but you do have to have HTML, and you should have CSS, or else your page is going to look super ugly. The programs that sent the web page to the user's computer is referred to as the backend, and the pages themselves, which are made up of HTML, CSS, and JavaScript, are referred to as the front end. Some programmers and developers do both, but you can specialize in one or the other with one particular group of technology. So in other words, not only can you specialize in back end or front end, but some people specialize in back end using PHP and MongoDB, which is a database program, and Apache web server, whereas other people specialize in back end using something called ASP.NET, which is the kind of like the Microsoft back end server system. And other people specialize using Node.js, which is a JavaScript backend system. Common terminology. All right, so this is important. So if you've made it this far, trust me, you're gonna want this juicy information here, because when I first started this crap, like I was bombarded by all this freaking terminology, and it confused the hell out of me. And there's not really one place that you can learn all of this stuff, and this will really, really, really help you as a newcomer to know what the hell is going on. Because one thing that's really confusing, and I think is kind of a weakness or annoying about web development, is there's all these different, like you get bombarded with HTML, CSS, JavaScript, like freaking C#, ASP.NET, MVC, MVVM, like freaking APIs, JSON, AJAX, REST. Like you're like, what the hell is all this crap? You know, and it's like, it sucks because you go online and you're trying to make a simple site, or you're trying to work with the little bit that you just learned, and then you start chatting or asking a question, and then somebody's like, oh yeah, you got to use the RESTful services to connect to this API to download this JSON data, and you're like, whoa, like what is going on here? You know, you have no idea what's going on. So I'm going to try to clear some of this stuff up for you, and I'm going to try to touch on the basics. I can't explain all of it, obviously, but I can really do my best to enlighten you here so you get a picture of what's really going on here. So you're going to hear a lot of things called frameworks. Frameworks are setups that allow developers to better accomplish a task, basically, okay? And what do I mean by that? Okay, so let's say you're going to do a specific task in programming. In fact, let me just show you something here real quick. I'm going to show you guys, I'm going to give you a little demo. And you might be like, what the hell is going on? But that's okay, because I'm going to explain to you what's going on in just a second. I'm going to start this program called Visual Studio. And what this program does is it is called an IDE. That's another term you're going to hear. All that is it's called the Integrated Development Environment, and it basically is a glorified text editor. It's like Microsoft Word, but for programmers, but it does a lot of other cool things. So I'm going to show you guys right now what a framework kind of is. Okay, so let's say I want to make a website, and I could either make that website from absolute scratch. Like, I could literally go into Notepad, and I could be like, doc type, HTML, HTML, head, and then I could just write out all the code here. And then I could go, and that would be like part of my my front end code. And then I could actually go and start writing like server software in here using like, you know, something like PHP or C# or JavaScript, you know, and I could start writing like all kinds of crazy stuff. You know, I could write like function, blah, 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 you know, var I equals 56. You know, I could just start writing all this code basically in Notepad, and I could make an awesome website this way. Like, theoretically, you could do that. You could make like a freaking Call of Duty by doing this. But you would have, it would take you like 20 years, because you would be reinventing the wheel. You would be basically just doing everything from scratch. Like, in other words, it's like if you wanted to build a car and you didn't ask anybody for help. You didn't find out how anything was done, and you just reinvented the engine and started from absolute scratch and like just figured it all out on your own. That would take way longer than it would be if you contacted people and used other people's resources and used like somebody's mechanic shop to build the car. Well, think of a mechanic shop and a mechanic's library of books, or an engineer's library of books. Think of that as a framework for building a car. Okay, that is basically what a framework is in software development as well. So let me show you what I mean by this right now. I'm going to show you some frameworks here. I will show you, well, we're doing web, so I'll show you a web framework. So I'm going to do an ASP.NET web application. And all this is this is just one framework. This is Microsoft's framework for building a website, okay? And I'm just going to call this framework demo, okay? And I'm going to hit OK. Now, see how it has these templates here? These are part of the framework. This is like, basically, I can set something up with a web forms template or an MVC template or a web API template. I'm going to show you a web forms template, okay? So, see, it's doing work right now. That's why we're waiting. And the work it's doing is it's setting up the framework. It's setting up a framework for me to build a website that will basically give me a whole bunch of resources that I need and do things that would be repetitive tasks that I should not have to do every single time I want to make a new website or a new web page. Okay. Now, see what I have here? They already gave me a layout, and they already included a bunch of files and things we call libraries, which are just pre-written code that have been written by other programmers that we reference and we use in our program. You can actually make your own library as well. It's nothing but just pre-written code. So see what it's done here? It set me up an about page, and it set me up an index page. It set me up a whole bunch of stuff here. A default page. They call their index a default page. So if you were to go to this website, you would already have a page. So if you uploaded this default page, this whole file system onto a server, and you went to that server, then you via the internet on your browser, you would already have an entire setup. Well, this is a framework. This allows me to work with something, and I can modify this stuff and add my own content here and make it my own. And it allows me to make a certain style of a website, basically. So this is one example. There's other frameworks out there. Angular is another framework. See, what I'm showing you here is a back-end framework. It's using the programming language C# for a lot of things. Okay, and also MVC is also another back-end framework, which I could have shown you, but it's kind of complicated. So I chose not to show it to you. So that's one framework. There's another framework called Angular. You'll see this a lot. Angular 2. This is a front-end framework. This logo right here. See this? See, it says right here, Angular 2, one framework. Let's read about it. Let's go. What's Angular 2? Let's see, Wikipedia. Complete JavaScript-based open source front-end web application framework, mainly maintained by Google and by a community of individuals and corporations that address many of the challenges, blah, blah, blah. Okay, so, I mean, we could even Google, like, a software framework if you're having a hard time understanding what this is. Software framework is an abstraction in which software providing generic functionality can be selectively changed by additional user-written code, thus providing application-specific software. Basically, yeah, it's reusable software that provides particular functionality as part of a larger platform to facilitate blah, blah, blah. Okay, so that gets really technical, but basically all they're saying is that you can reuse it's basically like I said, think of it as a mechanic shop for building and working on a car. Well, this is a nice setup for building and working on software of a particular type. We have Angular, we have React, we have ASP.NET, we have all kinds of other frameworks. They're everywhere. There's also something called libraries, which is a little bit simpler to understand. A library is just code that is already written and is reused by other programmers. And libraries are often inside frameworks. They're a part of a framework. You can make your own library by just writing some code and then saving it in a file and then referencing that code in future programs or giving it to other people so that they can use in their programs. That's what jQuery is. jQuery is a JavaScript library. Bootstrap is a CSS library. Okay, that's what libraries are. And you're going to hear a ton about Bootstrap and jQuery. Okay, so let's move on. As I said here, if you have a hard time understanding that concept, in law, there's common law, which are written rules that society must follow. And there is also case law, which are previous cases where rulings that are referenced basically when determining current cases. Think of libraries as case law for programmers, except instead of it being law, it is customizable and can be altered by anyone who wants to tweak or improve the code. So it's basically code that people reference. Okay, now you're going to hear a lot about these things called APIs. This is very important too. APIs allow our application and program or code to use other applications, functions, and data. So, for example, Google, Twitter, Google Maps, Facebook, Yelp, Twitch, etc. They all have APIs. And the two common components of APIs are libraries. So, for example, Yelp API comes with functions to work with Yelp. So if I go to GitHub and I download the Yelp C# API, it's going to be pre-written C# code that allows my program to plug in and work with Yelp's server, basically, to use Yelp's functions, such as pulling down Yelp reviews or location information or white page business information. Data access server. Another way you'll hear people refer to APIs is they'll be like, use the API, use the Wikipedia API and make a JavaScript program that searches Wikipedia and gets a Wikipedia article out. Well, in this case, you're not really going to be using Wikipedia's actual libraries. Instead, what you're going to be doing is you're going to be using JavaScript code to connect to Wikipedia's API server and just pull data from that API. So the actual server program that sits on Yelp's computer or Wikipedia's computer, which feeds our program the information, is also referred to as an API. And a lot of times you'll see api.something.com or something.com/API. That is just the domain or the location on their server that is being used where the API is actually set up. This prevents us from having to make our own Yelp all over again or our own Google Maps all over again just to use functionality that Yelp and Google Maps use or already have, for example. So the important thing to note here is that APIs allow you to make really cool stuff. Once you know a programming language, you need to start learning APIs to make cool programs. Learning APIs is somewhat separate from learning the language itself. So, for example, if you learn JavaScript, it's like, okay, cool, you can move stuff around a page and you can do dynamic stuff and you can make a JavaScript calculator and stuff like that. But in order to really make a nice application these days, you're going to be using APIs. You're going to, for example, let's say you want to make an application that will find all of the nearest restaurants and display reviews for them or display the different deals that they have every week or something for these restaurants. and then map these restaurants out so that the user can find directions to the restaurants. Well, you're not going to want to write all that code. What you're going to do is you're going to write some of the code, and then you're going to use the Google Maps API or the Yelp API to actually map out the restaurant. Or, for example, you could use the Yelp API to actually find the restaurants and get reviews for the restaurants from Yelp. And then your code will actually, do whatever it is that you want to do with these reviews and this restaurant information and display it the way you want to display it. But then you're going to use Google Maps API to actually, display directions and map it out, because it would take you far, far too long to try and reinvent Google Maps. Trust me. So knowing APIs and frameworks is what makes you a skillful developer and what makes you hireable. I mean, this is if you go seriously, stop the video and go and go to Indeed, go to Stack Overflow jobs, and just look up developer jobs, look up programming jobs. What you'll find is that people don't just post job postings for a programmer. They don't say I want a C# programmer, or I want a C++ programmer, or I want a JavaScript programmer. Okay. What they're going to do is they're going to post things like, we need a guy or a girl with experience working with Angular and using React and using ASP.NET MVC, or using MongoDB, or we need someone with experience using the Twitch API, or using the Yelp or the Google APIs, and this and that, because just learning a programming language doesn't make you a developer. It's like learning the English language doesn't make you a lawyer or an architect, okay? You have to learn English, and then you have to become an architect who uses English, or a lawyer who uses the English language. It's the same thing in programming. It's like, okay, it's cool that you spent all this time reading this thick book, but now that you know that language, you actually have to start learning these APIs and these libraries and these frameworks to make you a useful developer and somebody that an employer wants to hire, and that can make good products for somebody. You can make simple products and simple things by just knowing a programming language, but you're not going to be able to make all the whiz-bang, cool, advanced stuff that is sold in the market and stuff like that. So knowing APIs and framework is what makes you skillful. Eventually, when you become really good, you can start making your own APIs and frameworks and reusing your own code. So more terminology. We already kind of went over some of these. User and end user, it just refers to a person who uses the application. It's like a customer or a virtual patron. Like if you were to talk about somebody at McDonald's, you would refer to them as a patron or a customer. Well, online, you would refer to them as a user. Client is a user's computer or machine. Server, we already discussed server a lot. Software developer, programmer, engineer, coder, etc. This can be confusing too. You're going to hear all these terms over and over again. They're pretty much all synonymous, but they do have differences, and those differences often depend on what the person likes to call themselves and what the organization likes to title that role. So, for example, a developer or an engineer may have other responsibilities in the project besides programming, writing, and debugging code. However, a coder, a person who is referred to as a coder, may also have these other responsibilities, but different companies may just refer to them differently. Although, from what I've seen, coder is more of a casual or informal term that programmers use to refer to themselves, but I don't typically see job listings for coders. Debugging. What is debugging? Debugging is simply removing errors and problems from programs and code. So when there's like a problem with your code, and someone's like, hey, this doesn't work right, or this crashes, now you have to go debug the code. Where should you start? This is another big question I hear all the time. And this is a subjective question, but ask yourself this. Are you more of a science geek / logical thinker, or do you appreciate visuals more? If the first applies to you, then you may want to start with backend by learning a language such as C# or Java, or PHP, or Node.js JavaScript. You can make all kinds of cool desktop programs to experiment with in these types of programming languages, especially with like C#, Java, C++. You can actually make like non-web programs, and like just a Windows program. And same way with Swift on Mac computers and Apple computers and stuff. You can just make cool non-internet, non-web programs that do things like play music, display pictures. You can actually even make your own web browser that connects to the internet, and stuff like that. And this is kind of a nice way to learn programming if you're really into the actual like logic coding and stuff like that. And if you're a little bit less into the visual stuff, I would recommend that you start with backend first. And then what's cool about most of these languages is that most of these languages have web frameworks, which allow them to be used, as a backend web programming language, for servers. So, for example, what I just showed you, ASP.NET, that is programmed in C#. So you can actually use C# to make Windows applications. Like if you wanted to make your own version of Excel or your own version of Microsoft Word, you can use C# to do that. But you can also use C# to run a server to accept connections from clients, just like PHP or JavaScript and Node.js or Ruby and Python and all those other languages out there. And same with Java too. So if you enjoy working with colors, shapes, and would rather design, theme, and structure pages more than deal with data and programming, quote-unquote, logic. So in other words, if you like to position things on pages and deal with alignment and shapes, and you're just more of that type of person, you should definitely start with front-end HTML and CSS and then move to JavaScript. And what that'll do is that will, at the very least, make you a front-end web developer, because the bulk of that is HTML and CSS. And it will also open you up to web design if you would rather do more of the designing side of things. But also, when you do move to JavaScript, JavaScript is a full-blown programming language at this point. So if you like JavaScript a lot, then chances are that you'll do just fine in the back-end world too, because JavaScript is very similar to languages like C# and Java and C++. So the advantages of both. Front end, sometimes you can have more instant gratification. You get to literally see your work in action on a page, sometimes instantly. Back end, you get the gratification that your code is making a web system more secure, faster, efficient, and that your system is providing the actual software which powers a website. For me, I'm a back-end guy. Like, I think that's really cool. It just makes me feel so cool when I can hook up a database to a server and successfully transmit and store data that is inputted by a user all over the world, and keep that in my database, and then pull that data out and display that data. I think that's really cool. And being able to make things quicker and more efficient and all that stuff really appeals to me. So I'm more of a back-end guy, but I am challenging myself to be good at, or at least decent at, front end as well, which is definitely harder for me, but I'm starting to actually enjoy front end as well. So the choice is yours. It's a vast world. Try not to get overwhelmed. Web development may not be for you. You can still be a desktop application programmer. For example, as I said earlier, you can make desktop applications. Some examples of desktop applications are Adobe Photoshop, actually web browsers themselves like Firefox, Internet Explorer, Chrome, and Adobe Premiere video editing software, and all kinds of software that's used by companies. Like if you've ever worked at a restaurant, the software that's used on their cash registers, the software used by police officers and firefighters on their computers. All that stuff is all desktop application software. And even like your apps on your phone, Like all the stuff that you download onto the phone is really a desktop application. And even though most of these things hook up to the web these days, they're still desktop applications. However, yeah, we are seeing a trend in more and more programs becoming web-based. A good example of this would be Google Docs. See, like we used to only be able to use like Lotus Word Pro, Microsoft Word. I think there's something called Coral or something. But now you could actually go to docs.google.com and you can have, almost a full-blown Microsoft Word type of thing all in your browser. So that is a good example of a web app. Something that used to be a desktop application that is now becoming a web application. All right, so you made it. That's pretty much all I'm going to cover here. I might give you a little bonus real quick and just talk about some of that other crap I was telling you. You're going to hear the word JSON a lot, JSON. All JSON really is it is a format that a web server uses to send data to the client. That's all it is. So if you hear the word JSON or XML, these are just formats. So we already know servers send data to the client machine. So your client, via your internet browser or web browser, gets on the internet using the web, contacts the server, says, "Hey, I need this," and then when the server actually sends the data to the browser, it can send it in different formats, which, this is kind of part of that whole World Wide Web thing. But when your front end application or code wants to connect to an API, like I told you, like for example, if you need to pull down business information from Yelp, you're going to get that business information in a format called JSON, JSON. And if you go look it up, I'll show you a good example real quick here. I'll show you real quick. JSON formatting. Check this out. It's going to look kind of ugly to you, but this is like a JSON format here. And all this does is it's a standard format that allows your programs to accept data from someone else's program or API, and it can read that data in a standardized way. That's it. And XML formatting is the same way, except it's older and it's being replaced by JSON more and more now. But I'll show you. It uses these tags, and these tags are kind of less efficient and in some ways can be kind of ugly. Like there's all these tags here. It looks kind of like HTML. So that's really all you need to know about that. But just Google these things. Google JSON. You're going to be using JSON a lot if you become a web developer. So I wanted to cover JSON and XML, and I also wanted to cover these other things real quick. I mentioned one earlier. It's called REST, or RESTful Service. All that is it's referring to this standard way that computers communicate with one another. So in other words, the way your web browser is actually asking and requesting the information from the web server is using these things called get, put, post, delete, and I'll just stick with those. I think there's like another one or two, but it's using these things, and all these are just standard ways for your computer to communicate with the web server or with the server computer. And for example, when you go to a website, you're actually sending that server a GET request. And the GET request is saying, "Hey server, I want this information," and the server is then basically sending that information back to your computer. So it's using these methods, and the standard is called REST, RESTful Services, and you can go and read more about that. I'll probably put something in the description or in an annotation. Another thing you're going to hear about is CRUD, CRUD. That stands for, I think it's create. I always forget the R, but I know the last one is delete. Create, read, update, and delete, I believe. Let me double check that so I'm not giving you wrong information here. Create, read, update, delete. There we go. I always forget that one because I don't really talk about it that much. But all that is basically the methods that a program does very things. You know, how is it creating, reading something, updating, and deleting? So, for example, if I make a program that writes to and from the database, I'm going to have a function in my program that creates database entries. I'm going to have a function in my program that reads database entries. I'm going to have a function in my program that updates already existing entries, because at that point we're not creating, we're updating. And then I'm going to have something in my program that will delete entries. So if like a user deletes their account, we're going to delete their entry out of the database. So that's what that is. So I've told you about APIs, frameworks, libraries, REST, CRUD, JSON, a little bit about Node.js. So that is a lot of information. So if you made it all the way through this, like, I'm seriously applauding you. If you didn't, then I don't blame you. I would have paused this video and stopped it and come back probably like 10 times because it's a lot of stuff. But I just wanted to kind of have one local central area where you can kind of get these concepts explained and connected together. So now you know when you're talking to people, when they refer to all these different things, what they are. Okay. So I hope that really helped you guys. And sorry for the lengthy video. I think what I'm going to try to do is index it too in the description, so that way you can kind of search through the whole thing. But I guess at this point, if you got this far, then it doesn't really matter to you. So anyway, have a great day, and thanks for watching, and stay tuned for more from What the Hell Programming. All right, guys, that was it.